Good afternoon, all. Let us continue our learning of the subject discrete mathematics. We are into Unit 1, wherein we are learning logic, propositional equivalence, predicates, and quantifiers. Let us continue. Let us look at few of the laws which will help us in solving the problem of logical equivalences, tautologies. We'll take the most popular one first, that is De Morgan's law. The De Morgan's law states that if you have something like this, not of P or and Q, that can be represented as not of P or not of Q. If you have not of P or Q, that can be represented as not of P and not of Q. Similarly, you have a double negation law. Not of P will be equal to P. Then you have a distributed law. See, P or Q and R can be represented as P or Q and P or R. Say you have P and Q or R, it can be represented as P and Q or P and R. Similarly, you have negation laws. Suppose you have P or not P, that will be represented as truth. And if you have P and not P, that will be represented as false. Absorption law says that if you have something like this, P and P, P or P and Q, that can be represented as P. And if you have P and P or Q, that can be represented as P. So, same thing is mentioned here, De Morgan's law, then the negation law, P or not P equal to true, P and not P equal to false. Double negation law is not of P is P. Then you have a distributed law where you have P or Q and R is represented as P or Q and P or R. P and Q or R is represented as P and Q or P and R. You have an identity law wherein P and true will be represented as P, P or false will be represented as P. You have an associative law where P or Q or R can be represented as P or Q or R, and P and Q and R will be represented P and Q and R. These will be helpful for us in solving today's problems. So today we are not going to make use of the truth table for proving tautology or for proving logical equivalence. So let us look at the first problem. What the first problem is asking, it is asking you to prove that the two propositions are logically equivalent, but you are not using the truth table. Though I mentioned here using, it should be without using. So what is the problem? The first proposition is not of P or not of P and Q. The second proposition is not of P and not of Q. They are logically equivalent, you have to prove. So we'll take the first proposition. The first proposition is not of P or not of P and Q. So I'll be applying the De Morgan's law on this. So if I apply the De Morgan's law on this, so it will be converted to not of P and not of P and Q. Hope you understood this. If not, let us again look at the De Morgan's law. What the De Morgan's law says, not of P and Q will be represented not of P or not of Q. Not of P or Q will be represented not of P and not of Q. So let us look at this problem now. We have this not of P or not of P and Q. So you can treat this as P, you can treat this as Q. So this will be not of P or Q. So not of P or Q can be represented as not of P and not of Q. So this is not of P and not of this entire proposition. Again, you can apply the De Morgan's law. So not of P written as it is and written as it is not. So not of P or not of Q. So now I'll be applying the double negation law. So this not of P will be P. So not of P and P or not of Q. So here we'll be applying the distributive law. Here we'll be applying the distributive law. So let us look at the distributive law. So P or Q and R will be P or Q and P or R, like this. So we are extending it, right? So what is this? This is not of P and P or not of Q. So when we are applying the distributive law, this becomes not of P and P or not of P and not of. So this becomes this. So not of P and P is false, that you know. Not of P and P is false, while not of P or P is true. So not of P and not of Q is there. So this false or P. So using the identity law. So that comes to not of P and not of Q, and this is our not of P and not of Q. So these two, this we have converted into this, so both are logical. Hopefully you understood it. Let us go for the next problem. You have to show that P and Q implies P or Q is a tautology. Again, we are not going to make use of the truth table. So let us take this P and Q implies P or Q. So I'm using the implication rule here. Let us look at the implication. Implies A implies B. How I write A implies B? Not A or B. So this is A, this is B. So not A or B is not P and Q or P or Q. I'm applying the De Morgan's law here. So not of P or not of Q. This not of P and Q becomes not of P or not of Q because of the De Morgan's law, or P or Q as it is we have written. Now using associative law, we have converted this into this, not of P or P or not of Q or Q. So both are coming to truth. So truth or truth becomes truth. So it's a tautology. What is the definition of tautology? The output should be true. Again, I have to prove that this is tautology. P and Q implies P. So this is A implies B. A implies B can be written as what? Not A or B. So not P and Q or P. So this can be converted using De Morgan's as not P or not Q or P. So not P or not P or P becomes truth or not Q. So I'll be using the domination law. So T or not Q becomes truth. So it's a tautology. The second problem is P implies P or Q. So again A implies B. A implies B can be written as not A or B. So not P or P or Q. So not P or P or Q. So this not P or P is truth or Q. So again it's a tautology. Third problem, not P implies Q. So again A implies B. So not A or B. So not of P or P implies Q again can be converted not of P or Q. So not of P, double negation P, or not of P or Q. So P or not of P again truth or Q. It's a tautology again. Let us take the fourth problem. P and Q implies P implies Q. So this is A implies B. A implies B can be written as not A or B. So not P and Q or not of P or Q. So this can be represented not P or not Q or not P or Q. So not P or P, truth, not Q or Q, truth. So both are tautology. Fifth I skip because I found some error. I will do it later. Sixth, let us take. Not P implies Q implies not Q. So this is again A implies B. A implies B will be not A or B. So this will be not of not P or Q implies not Q. So again this becomes P and not Q, which implies not Q. So again this is A implies B relationship. So not of this entire term or not Q. So not of P or Q or not Q. So not P or Q. So that becomes a tautology. So this was a small session.